Okay, so yesterday we talked about ratios and proportions, and today we're going to move on to percentages. I'm starting here with a recent piece of news, the skydiver Fearless Felix, who jumped from 24 miles high. There were a couple different pieces of statistics in here that I thought were interesting, and we're actually going to use some of them later on to calculate some percentages. So the 24-mile height that he jumped from was approximately 128,100 feet. Of that distance, he spent 119.8 thousand feet in free fall. As it turns out, the jump itself was about 9 minutes long, and half of the time was in free fall. His fastest speed that he reached was 833.9 miles per hour. And in preparation for these jumps, he did a 15-mile high jump and an 18-mile high jump. So we'll come back to that data here a little bit later. Keep in mind that we're preparing for a benchmark that we're taking on Friday, and our focus today is on percent problems. So as we go through, these skills here marked today are the ones that you should be able to do by the end of today. The assignment that was due today being Monday, the answers are right here. You can pause the video if there's problems that you need to check. And if there's any questions on any of these, please just come to see me or ask another math teacher for some help. All right, going on into the actual lesson here. Percent literally means per 100. And so we say that percent is a ratio out of 100. When you see the symbol percent, that is replacing the notation of divide by 100. So 58% means 58 out of 100. Or as a decimal, when you divide that out, you have 58 100ths for every one of the original item. So if we're talking about dollars and we have 58% of the money, we have 58 cents for every $1. If we're talking about 58% of the hours that you worked, then we're talking about 58 100ths of an hour for every 1 hour. Okay? 6%, make sure you don't make the mistake of writing 0.6. This is not the same thing. 0.6 is 6/10 or 60%. To get 6%, we want 6 100ths, and that would look like this, 0.06. Notice anytime you're over 100%, when you divide by 100, to get the decimal form of it, you will have a decimal greater than 1 because you have more than 100%. And then a decimal percentage, just because you see a decimal point here doesn't mean it's in decimal form. If you see the percent symbol, that means out of 100. So we still write the 3.25 out of 100. And when we divide that, notice how the decimal place actually moves back 2 places, and we get 0.0325 for every one. So that's what percent means. Now how we calculate it. Let's say you're getting paid 4.5% of your sales as a bonus, and this is referred to as a commission. It's an incentive to sell more. If you're selling $285, you're going to get paid 4.5% of that. So we can think visually about this as the entire 100% is the amount you sold. And so if I put the dollar amounts over here, this is $285 equates to the entire 100%. I'm getting paid 4.5%, so that would be this bottom portion here. I'm getting paid that percent of my sales in my pocket. And so the question is, how many dollars here is worth the 4.5%? We want equivalent ratios. So we want the ratio of 4.5 over 100 to be the same as the ratio of this unknown dollar amount, X, over 285. Essentially, when I set up a percentage with a proportion, I'm putting on top the part that refers to that percentage. So the percent that we refer to is the part that we're looking for. So this is part, not raft. And on the bottom is the whole amount that I want a percent of, where in percentage form, the whole amount is the 100%. Once you've got the percentage or the proportion set up, we know that in any proportion, the cross products, or what we get going across the equals, those cross products will be equal to each other. So I know that 4.5 times 285 has to be equal to 100%. times x. And then to solve this, once I multiply my 4.5 by 285, I'm going to divide both sides by 100 so that I can get my x value alone. And I can figure out then that x is approximately, give me one moment to calculate here. All right, so I got $12.825, and since we're talking about money, we're going to round this and we'll call it $12.83. Make sure you put that dollar sign on there as a label. Now, the method that we just used there to solve this problem was what's called a proportion method, where I set up a ratio that compares my percentages and then a ratio that compares the actual values that I'm referring to, in this case, dollars. Another way that we could have solved this problem, and I'll use this other method for the next problem, another way I could have solved this problem is using an equation method, or the idea that a percent means a number of hundredths of your original item. So since I'm trying to take, again, 4.5% of my sales, I'm going to take the amount of sales and I'm going to divide by 100 to get each 1%, and then I'm going to multiply that result by 4.5 because that's how many of those 1% I want. Now, since my sales right now is not written as a fraction, when I write the sales here, I'm going to write it over 1 so I can see this as a multiplication of two fractions. Or I'm going to do this division first and get 0.045 and just multiply that amount by my sales. This is the method a lot of people prefer as they get more comfortable with percents, is just to simply say you're going to take that percentage as a decimal, so divide by 100, and you're going to multiply it by what you want a percent of, and that will then give you the answer that you're looking for. So in this case, we take the 1596.50, which is my sales, and I would multiply it by the percent that I'm trying to find, 0.045. And when I calculate this, it will tell me the amount of commission, or in other words, the part that is equal to 4.5%, where this is my percentage that I wanted, and this is the whole amount that I'm taking the percent of. And in this case, when I multiply it out and then I round to the nearest penny, I get $71.84 as my amount of commission when I sell $1,596.50 worth of items. Now, a slight twist on this, what if we know the dollars of commission we're getting paid? In other words, we know that when we take 4.5% of my sales, I get $100 out. So thinking about it in terms of the equation that we used the last time, that sales times the percentage equals the commission, then I'm going to come here and do the same thing. My percentage multiplied by my sales, which this time I don't know, should equal $100. And in order to solve for sales in this case, I'm going to need to undo that multiplication. So I'm going to be dividing by the coefficient, 0.045. And when I take that $100 and divide it by 0.045, I end up getting 2,000. This is my sales now. I get $2,222.22. I do need to round because, again, that decimal actually continues on as true repeating, and we're rounding to the nearest dollar. Another way I could have done that problem I'll use down here was the proportion method. Notice that when I'm setting up this problem, again, I use my percent ratio. So my percent ratio takes the percent, 4.5, out of 100, and then my dollar ratio. But what I need to remember is that the denominator here, the 100%, is the whole amount that I'm taking a percent of, which in this case is the sales. I'm getting a percent of my sales. And the top number is the part that is equivalent to the 4.5%, which in this case is the commission. And so the 375 goes in the numerator of this problem, not the denominator like we did earlier, because in this case it's the commission we know and the sales we don't. So just like before, Because it is a proportion, I can find those cross products. 4.5 times x equals 375 times 100. And then I'm going to divide both sides by the coefficient of x, which here is 4.5. And when I do that, I end up with a total of $8,333.33 would be the amount of sales that I would need. Now I want to make sure this seems reasonable. In my last problem, I had $2,000 when I wanted a commission of $100. This commission is almost 4 times as much, so I should expect this answer to be almost 4 times as much. And it is. All right, going back to Fearless Felix, we're being asked what percent of the total distance Felix spent in free fall. So we want a percent of the total that was free fall. So in order to do this, we can either use the equation method, which says what percent, what over 100, of the total here was 128,100, was equal to the free fall amount. And to solve this equation, we're going to have to do 2 things. One of the things that we'll need to do is to get rid of this 128,100. So we're going to divide both sides by that because it's being multiplied. So I do that on both sides. And notice now it says x over 100 equals 119,846 over 128,100. This, by the way, is actually the start of the other method that you could have used, which is the proportion method, where you're taking the part, the percentage piece here, over the whole. Again, the whole, when we're talking about percent, is always 100, equals the part over the whole. And since we wanted the total distance to be the thing I'm taking a percent of, that tells me this is the whole amount. And I want to know what percent was free fall, so that tells me that the free fall is the part that I'm finding as the percentage. So that's how I know I'm going to set it up this way. Now it's just a matter of doing this division over here to figure out what x over 100 is, and then multiplying both sides by 100 in order to get the x value by itself. And so if we take out our calculators now and do those calculations, we come up with 93.556, or about 93.6%. So even though 50% of the time was spent in free fall, 93.6% of the distance was spent in free fall. And that makes sense because you are traveling faster in your free fall, so you'll cover more of your distance. All right, so you should be prepared to go through and do the assignment now. This assignment is due on Tuesday of this week. It's practicing with percentages, just basic percentages, and then also some of the more complex percentages in application. We'll correct this tomorrow and come and ask questions on anything.